Okay, so in last lecture, we covered the topic shortest path using Floyd algorithm, right? Now today, the next problem that we can solve using the dynamic programming, that is matrix chain multiplication or chain matrix multiplication, right? Now input for this problem is n matrices A1, A2 up to an of dimension P1 cross P2, P2 cross P3, P3 cross P4 up to Pn cross Pn plus 1 respectively, right? And output should be the matrix product A1, A2 up to An, right? Now what is matrix chain problem, right? So problem is uh, as we want to uh, multiply the number of matrices, right? So it would take minimum number of computation to derive the product, right? We have to find minimum number of computation to derive the final product A1, A2 up to An, right? Now let us take two matrix A and B, right? A P cross Q and B Q cross R, right? And this we want to perform the multiplication for these two matrices, right? So resultant matrix will be like C is equals to A into B, right? Where dimensions for C are P cross R, right? So we can write like this: Cij is equals to sigma of K is equals to 1 to Q Aik Bkj, right? Value of I is between 1 to P and value of J is between 1 to R, right? Where P and Q are dimensions for A matrix, Q and R are dimensions for B matrix, right? Now suppose we have matrix A 2 comma 3 and matrix B 3 comma 2, right? So product C is equals to A into B, right? So what will be the dimension for C? That is 2 cross 2, right? So total number of scalar multiplication required are P into Q into R, that is 2 into 3 into 2. P and Q are the dimension for A, Q and R are the dimension for B, right? So Q is common, so total number of scalar multiplication required to perform the multiplication is P into Q into R, that is 2 into 3 into 2 is equals to 12, right? So you can see here, right? So these are the scalar multiplication required, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 to perform multiplication of A and B matrix, right? Now we want to calculate the product of more than two matrices, right? This is simple if we want to perform the multiplication for two matrices, right? But if we want to perform the multiplication of more than two matrices, right, then matrix multiplication is associative, right? So if we want to perform the product of four matrices A, B, C, D, right? So these are different ways, right, to multiply four matrices using different five distinct ways, right, using the parentheses, right? So first way is multiply A and B, right? This result will be R1, right? So how many multiplication? Sorry. Perform 5, 7, 8, 5, right? Then dimension for R1 is 13 to 89, right? Then multiplies R1 with C, right? So 13 into 89 multiplied with 89 into 3, so that is 13 into 3, right? So dimension for R2 is N, Finally, whole R2 will be multiplied with D, right? So total you require how many scalar multiplication? 10,582, right? Same way you can parenthesize this 4 matrix like this also, right? So these are the 5 different ways, right, to parenthesize 4 matrices to perform the multiplication, right? Now, this second option, right, contains highest scalar multiplication, and the third option contains lowest scalar multiplication, right? So these are different ways to perform the matrix multiplication, right? Now, if we use the dynamic programming to perform the multiplication, right? So we can solve this problem, right? In this example, right? All these 5 distinct ways are give you the final answer, final multiplication answer, right? For the matrix A, B, C, and D, right? But all these different ways, right, are gives you different types of dimensions, right? Or different શું કહેવાય computation time, right? So if we want to solve this problem using if we want to solve this problem, right, then we can use the dynamic programming concept, right? Now in dynamic programming, right, for matrix chain multiplication, right, first step is decide the structure of optimal parenthesization, right? Then second step is recursive solution, third step is compute optimal cost, right? And this will give you the final answer, right? So consider a matrix Mij, right, which is used to store the cost of multiplications, right? Now, first is to generate the, right, you have to use the steps, right, different steps. So step number 1, if in Mij value of I and j are same, right, then Mij is equals to 0, right? We use the Mij matrix to store the cost of multiplication, right? Cost of multiplication means this: 10582 5402 54201 2856 4055 26418, right? So this is the cost of multiplication, right? So in Mij, if value of I and j are same, right, then Mij is equals to 0, right? Now if j is equals to I plus 1, right, then Mij is equals to pi minus 1 dot pi plus 1, right? Now what is pi minus 1, pi plus 1, right? So pi minus 1, pi plus 1 are the dimensions for respective matrices, right? And if value of I is less than j, right, then what will be the cost of that particular cell in Mij? So that is Mij is equals to minimum of Mik plus Mk plus 1j plus pi minus 1 dot pk dot pj with value of k is between I and j, right? So all of you write down these 3 steps in your notebook. All of you write down these 3 steps in your notebook, right? We use these steps, right, to compute the optimal cost. And using this optimal cost, we can find the correct parenthesis for the multiply the matrices. Write down the steps in your notebook. right? Now let us understand the matrix chain. Okay, done. Okay. Now, so here are the dimensions for the matrices, right? So P0 is equals to 5, P1 is equals to 4, P2 is equals to 6, P3 is equals to 2, and P4 is equals to 7, right? So using these dimensions, uh, we can create the four matrices. A is equals to 5 plus 4, oh, sorry, 5 cross 4, right? Using P0 and P1. Using P1 and P2, create B 4 cross 6, C 6 cross 2, and D 2 cross 7. Right? So, like this. Right? Now, next is create a table or create a matrices, right? MIJ. Right? So, in MIJ, right? When oh, sorry. Okay. So, create a matrix, right, or table for MIJ, right? Now, value of I and J, right, depends on total number of matrices, right? So if the total number of matrices are 4, right, then value of I is equals to 4, value of J is equals to 4, right? I is equals to total number of rows, J is equals to total number of columns, right? Now in step 1, to create a matrix Mij is if value of I is equals to J, right? Then what would be the value of Mij? 0, right? So here M11, M22, M33 and M44 are 0, right? M11, M22, M33 and M44 are 0, right? Now in this matrix, right, when value of I, right, is greater than, right, value of I is greater than the value of J, right, in this case dash dash dash, right, compute the optimal cost for this much cells only, right? Now next is if J is equals to I plus 1, right? So first case is if I is equals to J, then put 0, right? So second step is if J is equals to I plus 1, right? Then value of Mij is equals to Pi minus 1 dot Pi plus 1, right? Now for M12, right? For M12, value of I is 1, right? And value of J is I plus 1, right? So you can compute like this. M12 is equals to value of I is 1. So P1 minus 1, 0. So P0 dot P1 dot P1 plus 1, that is P2. So P0 into P1 into P2, right? So what will be the P0? 5 into 4 into 6. So that is 120, right? So this is the cost, right, for M1, right? This is the cost for M12. It means this is the cost to multiply first matrices with second matrices, right? So M12 is 120, right? Same. Next M23. Next is M23, right? For M23, value of I is equals to 2 and value of J is equals to I plus 1, that is 2 plus 1 is equals to 3, right? Same way, put the value of Pi minus 1, so that is P2 minus 1, P1 multiply with P2 multiply with P2 plus 1, that is P3, right? So 4 into 6 into 2, that is 48, right? So cost, uh, hello. So the cost to multiply the second matrices with the third matrices is 48. Right? आइए से समझ पड़ी बदन.
Yes, ma'am.
Okay. Now next is
Yes, ma'am.
M34. Right? So for M34, I is equals to 3, J is equals to 3 plus 1, that is 4. Right? So you can use the same step. Right? So for M34, P2 into P3 into P4, that is 6 into 2 into 7, right? So this is the cost for multiplying the third matrices with fourth matrices, right? So that is 84, right? Now next is if value of I is not equals to J and value of J is not equals to I plus 1, right? So for all those cases, right, and value of I is not greater than J, right? It means value of I is always less than J. So for all those cases, right, Mij is equals to minimum of Mik plus Mk plus 1J plus Pi minus 1 dot Pk dot Pj, right? Now value of K is between I and J, right? Value of K is less or equals to I, sorry, value of K is greater or equals to I, right? And always less than value of J, right? So consider the case M13, right? M13. So here value of I is less than J, right? We have to find the value for this M13, right? So here I is less than J, right? So for M13, right, I is equals to 1, J is equals to 3, right? And K is equals to 1 less or equals to K less than 3, right? So value of K will be 1 or 2, right? So value of 1, K will be 1 or 2. 1 less or equals to K less than 3. So value of K will be 1 or 2, right? So we'll find value for K is equals to 1, right? So for K is equal to 1, M13 equals to value of I, K and J in this equation, right? So M value of I is 1, right? So M1, right? K is equals to 1 plus M K plus 1. So that is 1 plus 1, 2, right? And value of J is 3. So M 3 plus Pi minus 1. Value of I is 1. So 1 minus 1, 0 into P1 into value of J is 3. So P3, right? Now what is the value of M11, right? So you can use this table, right, to put the value of M11. Value of M11 is 0, right? Value of M23 is 48, right? Plus P0 is 5 into 4 into 2, right? 5 into 4 into 2, right? So This is answer for M13 if value of k is equals to 0. Right? Now find same value. Now find same value M13 for k is equals to 2. Right? Because we have to find the mij value, right, for all the values of k, right, and minimum out of this, right, will be the final answer for mij, right. So for k is equals to 2, same way m13 is equals to m12, right, because value of k is equals to 2. So m12 plus m2 plus 1, that is 3, right, and value of j is 3 plus p0 into P2 into P3, right? So this will be the answer, that is 180, right? So which is minimum? 88, right? So write down 88 into M13, right? Now here, right, here what we do, we perform the multiplication of first matrices with fourth matrices, right? First matrices with third matrices, right? Or first matrices, sorry, with, right, third matrix, right? So these are the possible scalar multiplication, right? And which gives you uh, cheapest cost, right? That will be the selected for matrix multiplication, right? So here we select the M13 is equals to 88, right? Now same for M24, right? M24. Now for M24, I less than J, right? So value of I is equals to 2, J is equals to 4, and K is equals to 2, 3, right? Now all of you give me answer for K is equals to 2 for M24. Compute the answer for K is equals to 2, I is equals to 2, and J is equals to 4, and give me the answer for M24. Right here, value of k is used to decide the parenthesis. Right, આપણે brackets ક્યાં મૂકવાના છે to perform the multiplication, right? We have total 4 matrices, right? So we have to write down parentheses in such a way, right, that final multiplication will give you minimum cost, right? So what is the value for k equals to 2? That is 252, right? Now find the value for k is equals to 3. cost is minimum 104. So that is k is equals to 3. Right? Now find the value for M14. Right? Now for
મેમ
M14.
અવાજ બહુ સ્લો આવે છે.
Okay. હવે આવે છે?
યસ મેમ.
Okay. Now so find the value for M14. Right? For M14, I is equals to 1, J is equals to 4, and value of K is between 1 less or equals to K less than 4. So value of K will be 1, comma 2, comma 3. Right? So for K is equals to 1, find the value of M14. Right? So this will be 244, right? Now for k is equals to 2, find the value of M14, and k is equals to 3, find the value of M14. Right? All of you find the value for k is equals to 1, k is equals to 2, and k is equals to 3. Right? So for k is equals to 1, we get 244, k is equals to 2, we get 414, k is equals to 3, we get 158. Right? So after calculating, right, we get the matrix table like this, right? And at the end, at M14, right, at M14, we determines the optimal cost, that is 158, right? So this is the optimal cost to multiply the four matrices A, B, C, D, right, with having dimension P0 is equals to 5, P1 is equals to 4, P2 is equals to 6, P3 is equals to 2, and P4 is to 7, right? So આપણે હવે optimal cost we get, right? Optimal cost हमें मिल गई है, right? अब हमें क्या फाइंड करना है कि कौन सी सीक्वेंस में optimal parenthesization हुआ होगा, that gives us this optimal cost. Right? From here you can find that to multiply the four matrices, right, the minimum optimal cost is 158. Right? So it required to only total 158 scalar multiplication. That is minimum. Right? But to get this optimal cost, right, which optimal parenthesis is used, right, that we have to find. Right? Now to find the optimal parenthesis, right, you can use this method, right? So how to parenthesize the matrices, right? So we have here total four matrices A, B, C, D, right? And we have one optimal table, right? MIJ, right? So using this table, right? Now we are going to parenthesize these matrices, right? Now what is parenthesize of matrices, right? Parenthesis gives us the order of multiplication. Right? If you want to multiply more than two matrices, right, so then you have to perform the parenthesization. Right? Using the parenthesization, you can provide the order of multiplication. Right? And order of multiplication, right? How you parenthesize your matrices, right? Cost, the optimum cost is depends on this. રાઈટ કે તમે કયા મેટ્રાઇસીસનું પહેલા મલ્ટિપ્લિકેશન કરશો પછી એના આન્સરને કોની સાથે મલ્ટીપ્લાય કરશો રાઈટ ઇફ યુ ચેન્જ ધીસ ઓર્ડર then final cost will be different, right? So using this table, right, we get that optimum cost to multiply these four vertices are 158, right? So here you can see that, right, for value of M14, right, for value of M14 you get the optimum cost, right? And to get this optimum cost, what is the value of k? K is equals to 3, right? હવે અહીંયા થોડું ધ્યાનથી સમજો. It is little bit tricky, right? So here M14 gives you optimum cost, right? Now to obtain the optimum cost at M14, right? Which k value is used? K is equals to 3, right? So first three matrices are parenthesized together, right? And after three, pachi jetla but matrices, here we have only four matrices, right? So first three matrices are parenthesized together, right? And fourth will be separated, right? So this is the first parenthesis, right? Now for second group, right? To get the minimum cost for M13, right? For M13, right? You use value of k is equals to 1, right? So it means first matrix are separated and second and third are parenthesized together, right? So this is your final parenthesization, right? For multiplying these four matrices A, B, C, D, right? Having the dimensions P0 is equals to 5, P1 is equals to 4, P2 is equals to 6, P3 is equals to 2, and P4 is equals to 7, right? So first it will multiply B and C, right? First it will multiply B and C, then answer of B and C will be multiplied with A, right? And the whole answer of this multiplication will finally multiply with D. If you multiply this four matrices in this order, right, then you will get the optimum cost 158. Right? Now, if you change the parenthesis order, right, then optimum cost will be different. Right? So you will not get the 158 cost, right, to multiply this A, B, C, D. Right? Getting? Everybody understood how to parenthesize the matrices?
Yes, ma'am.
Anybody has any doubt in this? Okay. Okay. Only the parenthesization part or the whole example? Hini, only in the parenthesization part or okay, only the parenthesization. Okay. Okay. So here, right, we get the cost, right, at M14 position in our matrix, right, that 158, right? Now next step is the sequence of optimal parenthesization, which gives you the optimum cost 158, right? We have total four matrices, right? So we have to parenthesize these four matrices in such a way, right, that will gives us the optimum cost 158, right? Now to parent the matrices, right, you have to look back to your computation, right, to fill this table, right? So to fill this table, right, to for M14, right, starts from MIG, right? So last value of MIG is M14, right? So at M14, to get this optimum cost 158, right? What is the value of K? What is the value of k to get this optimum cost at M14? K is equals to 3, right? So value of k is equals to 3, right? It means start from 1 to, right? Right? This will be first parenthesis. First, second, and third matrices are parentized together, and fourth will be separated, right? Because value of k is equals to 3, right? For M14, value of k is equals to 3, right? Getting आटलू खबर पड़ी, right? Now, next is we reach at third, right? M for M14, value of k is equals to 3, right? Now we have one group A, B, C, right? So that is 1 and 3, right? So we have to see for M13, right? Because here fourth matrices are now separate, right? So we have to see for this parenthesis group, right? So 1, 2, and 3. So we have to see for M13, right? Now for M13, right, to get the M13 value 88, what will be the value of k? What is the value of k which we used? That is k is equals to 1, right? So we have to separate first matrices with second and third matrices, right? So parenthesized second and third matrices. So what is the meaning of the parenthesis? First be multiplied together, then with first matrices, and this after the four matrices. If you follow this parenthesis, right, it will give you the final optimum cost 158. Now getting Hini, right? I will give you some more example of matrix chain multiplication in assignment, right? Try to solve those examples, right? Then you can understand it very easily, right? Otherwise, I will provide you one small algorithm on classroom only, right, to perform this parenthesis, right, or steps how to perform this, how to write these parentheses for matrices, and that material I will provide you in classroom. So refer that material, uh, and try to solve the examples which I will provide you in assignment after completion of this chapter, right? And still you find any difficulty in matrix chain multiplication, then whenever you come in the college, right, then you can ask me, right? Now still anybody has any difficulty? If you, if anybody has any difficulty, ask me right now. I'm again explain this example, matrix chain multiplication.